Hello everyone, this is the experiment transistor as a switch. So we are going to see how this experiment to be performed in the lab as well as the explanation of the transistor as a switch experiment. So you can see the aim of this experiment is to study and perform transistor as a switch. So you can see here this is a transistor. So this transistor is actually you can see a common emitter transistor. So emitter is common at input as well as at the output side, where the input is connected at the input, or we can say at the base terminal, and the VCC supply is connected at the collector terminal. So what we are going to do, we are going to find out how this transistor is to be used as a switch. So you can see here, if the Vin is connected to E terminal or emitter terminal, means it is connected to actually ground. What will happen? The current that will not going to flow in this circuit. So what we can say, it is nothing but a open switch. So what we'll get? We'll get a V out maximum at this point, or we can say we are getting V out as approximately equal to VCC. Only voltage drop across RL will be there. So we are going to get a V out. So that will be the maximum, that is not equal to 0. So why this is so? Because if transistor is actually, if the transistor, you can see the transistor's characteristics of the common emitter. So in that, if the base is absent, the whatsoever the collector current is there, what will have this particular area, and that is active. So that particular area is called cutoff region. So that's why what we are getting output max, where the transistor is in cutoff state, means not working state. So it is nothing but an open switch. Okay, so that's why it is called as a transistor as a switch. Now in case of this, the second scenario where Vin is connected to VCC, so what will happen now? We are getting a current in the base. So as you know, IE is equal to IB plus IC. We actually has IC. Now we'll have IB as well. So that's why we'll get a current IE, and that IE current that is traveling towards the ground. So we can see this collector current is traveling towards the ground. So what is the meaning of this? According to this characteristics, you can see if the base current is there, the maximum base current will get the maximum collector current. But at that time, we can see this is in the area of saturation region. Saturation region means all the current will flow from IC towards the emitter terminal, means called it as a ground. So what will happen at that V out? This V out will be actually directly connected to ground, means it is equal to 0 volt. That's why we are saying it is to be as a closed switch. Okay, so to perform this experiment, we have to take this two scenario 1 and scenario 2. So that's why we have taken serial number 1 and serial number 2. So for that input side, we have input supply called ground and input supply VCC. So at that time, we can call ground to be as a logic 0 in case of our digital electronics, and VCC is considered to be as logic 1, and we are going to observe this output. So this output, according to theoretical point of view, if we connect LED in here, if we connect this Vout terminal, it should be connected to LED. So what will happen? This LED will be off when we have a ground terminal, and at that time we'll having a logic 1. Okay, and if the LED is on, means we are getting a ground, there will be a logic 0. So you can see that the logic 1 is converted into logic 0, logic 0 is converted into logic 1. So this transistor is also act as a switch and also act as a inverter. Okay, so let's look of how we are doing practical in the lab. This is a transistor as a switch circuit. We are having a variable potentiometer at the base terminal. LED is there, and we are going to have a BC107 common emitter transistor. So how we are going to connect it? So for that purpose, we need to put the regulated DC voltage to be as a 5 volt, and this 5 volt should be given to the VCC of the transistor as a switch socket, and ground should be connected to the ground. So kept in mind, while we are setting the power supply, always kept cos and phi of the current to the maximum, and the phi at middle, and then adjust the cos in such a way that phi should be adjusted for only zero point 0.2 or 0.1. So this is a 5 volt adjusted So look at the fine button. I have adjusted the fine so that it will become a 5 volt. Now what we are going to do while doing the connection, we have to keep in mind that we have to switch off the power supply. So while making the connection, I am going to switch off the power supply, and then I am going to make the connection. I have connected it to C. So kept in mind, the current knob should be kept to the maximum position. So you can see here the voltage as well at the out, so it will be considered to be as logic 0 or logic 1. So I am putting the digital multimeter. We are going to measure the DC voltage. So here it is showing that this 39.3 millivolt means it is approximately equal to 0 volt. So I am just changing the bias of the base or changing the voltage of the base. You can see the LED is off and we are getting 3.44 volt. So if I make the biasing to that like 0, so so in this way, by having ground logic 0, we are getting LED off. At that time logic is 1, and having VCC logic 1, the LED state is on and we are getting logic 0. So this is the way to have a transistor as a switch experiment at the laboratory. Thank you for patience.